Hi, everyone. Is it on? Yeah, okay, cool. Where's my presentation? Here. A few months is it now already, that in our own company, we did a symposium. And in that symposium, I asked the question, of course, regarding our industry, wouldn't it be nice if? So if I ask you, if you had a wish, wouldn't it be nice if, Karen, I have to take you as the first one.
If I have a Ferrari.
If you had a Ferrari. Okay, this is important for the factoring industry. No, come on. This is for you.
Full digital process in most factories.
Full digital processing.
One click.
Okay.
One second. One click, 1 second.
One click, 1 second.
Yes.
Yeah.
Thank you. One more. Wouldn't it be nice if, please? I know it's after lunch and it's difficult. Wouldn't it be nice if? Olga.
Well, you know my answer.
Come on. Yeah, but factoring.
If Russia fails,
If I don't have frauds in factories.
If you don't have fraud. Very nice. Wouldn't it be nice if?
If we have a good lead generator.
Good lead generator. Wouldn't it be nice if?
Factoring reduces.
It's not from
Ivan,
Yeah, I know.
come on. Out of your gut. Don't think.
If I knew the rate straight away.
If you knew the rates straight away. Okay. Okay, wouldn't it be nice if? So we asked that question to our clients in our symposium, as I said before, and here's the answer. This is not the answer. The answer was basically, wouldn't it be nice if we could predict, wouldn't it be nice if we could predict the future in business? I don't know if I want to know what will happen to me tomorrow, but wouldn't it be nice if we knew, and I take your idea, wouldn't it be nice if we knew when there was going to happen fraud or who, from where it would happen, right? Because this is an inherent part of our industry. So we came up with this idea a few years ago. It was one of our clusters that we thought of. And we said, wouldn't it be nice if we could look into the glass bulb and it would tell us what will happen? Obviously, that is not easy to do, but it's becoming easier to do nowadays. Because now we have a lot of data, we have a lot of computing power, and all of that together allows us to make predictions into the future. Computing power, data, and of course, good programmers. So we came up with something like this that was going to give us answers on if we're having good customers or not so good customers in our ecosystem. Yesterday in our workshop, we were talking about how large is an ecosystem in a particular factor's environment. And if you said, just for the sake of saying something, 200 clients, and each of them 200 clients, so we have 200 by 200 companies in that ecosystem, right? And if you have larger ones, well, then you have many more. So we're talking large ecosystems, a lot of companies, a lot of data, a lot of interactions between customers and debtors amongst each other, customers with customers, looking something like this. And this system is a live system. This is a picture. But the picture, if it was a living thing, and we have to think about a living thing here, that changes by the second, because there are interactions happening all the time between them, between each other, then you could probably anticipate what's going to happen. So what we said is, let's look at that, and let's see what could happen in a given system. So we asked our customers, what would be nice to know? You know, wouldn't it be nice if? And they gave us all these answers. Data security, competition, privacy, no Ferrari in here, but diversification of services, credit risk, etc., risk management, client relationship, and so on. So we thought, okay, out of those wishful thinking, wouldn't it be nice if, we could cover a bunch of them with with our analysis and predictive modeling in if you were using machine learning and artificial intelligence. So we could cover late payment, fraud and non-payments, risk management, and credit risk. Okay. So we thought, how do we get from the wish to the reality? And from the wish to the reality, we said we have to have machine learning approaches. What does that mean? Machine learning is a subset of artificial intelligence, and I don't want to go in detail what it's all about. I just want to give you some ideas on how that works in general. And it starts all over with so-called unsupervised learning. Unsupervised. Did I say that? Yeah. Unsupervised learning in the sense of you have just a lot of data. You put that into a tool, and the tool will tell you there's correlation, whether that makes sense or not. You know, like are more young boys being born when the sun or when the moon is out there, or vice versa, girls. The machine would tell you, yeah, there is a correlation. And if you believe that, well, then it may be true or may not be true. So unsupervised learning. Then we come into supervised learning. And what we do here is we start learning about fraud detection, image classification, customer retention, forecasting, and prediction, because we're giving the machine already hints on what makes sense on what the machine is detecting, okay? And last but not least, reinforcement learning, when the machine starts learning not only by our own input, but because the machine is also detecting itself and creating algorithms to learn when something is going in the wrong direction or whatever we want to detect. So from unsupervised learning to supervised learning to reinforcement learning. What do we want it to achieve? How do we work today? In conventional risk management, what do? We read financial statements and credit agency scores. We have payment behavior, industry analysis, market trends, and so on and so forth. So this is what happens today in 99.9% of the cases. So we rely at the end of the day on history, on the past, much less on the present meaning what's happening right now, and less on what could happen in the future. So what we're doing here is we really rely on financial statements that could be 1 year old, 2 years old sometimes, or credit agency scores. We know what happened when you rely on those. It can be the last time or the last time that you made a deal with someone. Lehman case, right? AAA, one day, bankrupt the next day. So payment behaviors, industry analysis, market trends. So what do we want to do with machine learning with what we saw before? We process big data, and data nowadays is a lot of data. In the 1940s, when all this artificial intelligence began with Alan Turing as the father of, we're processing 0 data, digitally or electronically. So we started in the 1940s. Nowadays, we're processing around 800 zettabytes. And that is a lot of data. If you look into your device, how much a zettabyte is all about. And also, the computing power has increased dramatically. When I studied artificial intelligence in the 1980s, we were able to do some computing. And Lisp programming was out there during that period of time. And then artificial intelligence became dormant. And it wasn't really until computer power came up again and the data was available that we started working with it. So process big data, and that allows us to detect, complex patterns in the sense that maybe something that we wouldn't detect at the very beginning that has a correlation and detect patterns. Adapt to market changes. This is very interesting because someone was asking me, Federico, are you also including information from third-party providers out there, that read what's happening out there in the world, the news, internet, etc. And I said, no, not really. We're not doing that right now. But perhaps it's not even necessary. Because if the system is working well, the system is detecting that through the numbers that are coming into the system. So yeah, you could probably use third-party information that's not in your ecosystem, but your ecosystem is the one that's mattering to you. And that's the one that will give you the answers. And it will adapt to market changes. Automate data task and reduce bias. Reducing bias means you're really off to what you consider, I believe that, or my gut feels are telling me the following. So it's much better when you rely on real data that's happening. It's like reading your own vital systems instead of looking at the mirror and saying, yeah, I'm good. But maybe something is happening inside yourself that's not so good. So look at the numbers, look at what's changing, and take the consequences or drive out what is necessary for that. So this is out, convention is out, and of course, this is in, right? So how do we work when we work with machine learning? We have to go through, or with predictive analysis processes. At the very beginning, what we do is we define a project, and then second, we do the data collection. Data collection is not so an easy thing to do. We have been now working with a client in doing a beta testing, and this has been taking us ages to get the real data that we need for doing our testing of our algorithm. So data collection, then the data analysis, cleaning of the data, of course, all that stuff, and then data analysis, which is an inherent part of machine learning. Then get the statistics out of the data that you have inside your, in your ecosystem, and then you start modeling. So what are all these numbers? And I'm not saying taking a picture, because what you saw at the beginning is just a picture. That's the instant situation of something that's happening at a particular moment. Boom. That could be good, could be bad, could be middle, you don't know. It's like the pictures that we take when we take pictures. And more importantly is what is happening in the, let's say, in the transitions, in the dynamic. So what's happening basically every moment, and what could probably be tomorrow. So modeling is important, and then you deploy it, of course. I'm probably running out of time. One more to go. Let's try if we can get this done. Why don't you try to hit? Oh, good, very well. Excellent, thank you. So this is a model that we have right now with some dummy data. And of course, this is not a complete ecosystem. One of the things that we have discovered also is this was a concept, and then after we figured, oh my God, with all these data that we have from our client, test client, we're talking really a lot of companies, it wouldn't look like this. So this is like just a little maquette, if you like so, on what it could be. So the green thumbs up means that you have that you can rely on that client, nothing is going to happen. So if we click on a green thumb up, let's say which one we tick. Let's say if it works. Okay, if we could do that, then you would see on clicking on a particular green thumbs up, you would see all the dependency that that client has with its debtors, and perhaps even with other clients, which also can be the case. Which industry it is in, which geography it's playing, and why it is not good at the moment. Because perhaps there are some debtors in its particular ecosystem, like in this one, in the red one, that are showing some developments, signs that are possibly scary. What could that be? Yesterday in the workshop we talked about it. If you always have a client that's paying late, but pays, that's not bad. He's paying a lot of money to you. vis-a-vis another one that's always paying punctual and suddenly starts paying late. So that's the one that you want to look at, right? And perhaps in the ecosystem that you've got with hundreds and thousands, hundreds of thousands of companies and invoices, et cetera, you don't see that happening. So in here, you detect changes, behavioral changes. And payment delays is one of them, a very obvious one. There are a number of other ones that are detected and put into the whole system, into the model. And that's why the system will tell you every day, every moment, at any time, 24/7, what's happening in your system. AI or AI and machine learning for predictive analysis. Thank you so much.